So far, we have observed that magnetic field is due to two reasons. Number one, due to moving charges as observed by SC or studied in 1820, and due to intrinsic properties of ions inside a substance. That is, we will discuss about diamagnet, ferromagnet, and paramagnet in future. This Biot-Stavart law is an extension of Oersted experiment. That is, what is the magnetic field at a point due to any current element. So far, we have observed that magnetic field at a point is due to moving charge or electric current as observed by SC or star in 1820, and due to intrinsic properties of ions, that is magnetic moment, in substances, which we'll discuss later, that the diamagnet, paramagnet, and ferromagnets. In this Biot-Savart law, we will discuss about the contribution of magnetic field at a point due to a current element. Suppose this is a conductor XY, arbitrary conductor XY. There is some steady current flowing from X to Y. Then this length of conductor can be divided into small elements of dl each, infinite number of small elements. Due to any current element idl, the magnetic field at any point around, at any distance r, the contribution of the field at the point due to this current element depends upon the distance, the element, and the angle between the direction of element and distance of the point. Biot-Savart's law gives an expression for magnetic field at a point. Magnetic field at a point due to a current element ideal. Consider a conductor XY. Consider a conductor XY with steady current I. Due to any element ideal, the magnetic field at a point magnetic field dB at a point P at distance r, is dB proportional to ideal. dB is inversely proportional to the square of distance. And dB is proportional to sine theta, where theta is the angle between ideal and R. That is dB proportional to ideal sin theta by r square, or in vector form dB is equal to some constant k I dl cross r by mod r cube. The constant of proportionality k, the constant of proportionality k is mu 0 by 4 pi in SI system. Where mu 0 is equal to 4 pi into 10 to the power minus 7 Weber per ampere meter, or it is also 4 pi into 10 minus 7 Tesla meter by ampere. Or B is equal to integration of dB is equal to mu 0 by 4 pi integration of I dl cross r by mod r cube, or you can write here mu 0 I. This equation 1 is known as Biot-Stavart's law. The equation 1 is known as Biot-Stavart's law. Weber is the SI unit of magnetic flux or magnetic lines of force, or magnetic lines of force. And Tesla is the SI unit of magnetic field. And magnetic field B is equal to flux per unit normal area. That is 1 Tesla is equal to 1 Weber per 1 meter square. Similarly, in CGS system, magnetic field is Gauss, which is Maxwell per meter square, centimeter square centimeter. Here we obtain that magnetic field B is equal to mu 0 I by 4 pi integration of dl cross r by mod r cube, or we can say B is equal to mu 0 I by 4 pi dl sin theta n cap by r square. And according to Coulomb's law, electric field is equal to 1 by 4 pi epsilon 0 q r cap by r square. There is a similarity. There are certain similarities. There are certain similarities between the two laws. One, the magnetic field at a point due to current element, and second, electric field at a point due to a charge. Number one, both obey inverse square law. Both obey inverse square law. That is, field is infinity or field is infinity. Field is 0 at infinity. Number two, both obey the principle of superposition. Obey the principle of superposition. That is, here magnetic field at the point is due to the contribution of magnetic field due to individual elements, and that is added vectorially as is observed in case of electric field due to number of charges. The resultant field is also obtained by the principle of superposition. Number three, magnetic field is due to a current element which is a vector, due to a current element ideal which is a vector. But electric field is due to a charge. Electric field is due to a charge which is a charge q, which is scalar. Magnetic field is along a line normal to the plane containing ideal and R. So this is normal to the plane from the element and to the distance or position vector, since there is a n cap, but electric field is along the line, joining the charge and the point. There is another obtained epsilon 0 mu 0. We can say that here you can write 4 pi epsilon 0 into mu 0 by 4 pi. Here you can write 1 by 9 into 10 to the power 9, and this is 10 to the power minus 7. So it is 1 by 9 into 10 to the power 16, which is 1 by 3 into 10 to the power 8 square of 3 into 10 to the power 8, that is 1 by c square, where c is the velocity light or velocity of electromagnetic wave. Or we can say that the velocity of electromagnetic wave c is equal to 1 by square root of epsilon 0 mu 0. So this is another relation connecting the electric field and magnetic field. Therefore, it was concluded that electromagnetic waves are the waves emitted out of magnetic field and electric field placed at right angle to each other. If the two fields are oscillating variable, then the wave emitted in the form of light or of various wavelengths, visible or beyond visible, that is ultraviolet or infrared, which we will discuss in electromagnetic chapter.